Welcome to the Calculus A section. In the previous section, we learned about how to find the derivative of the function with limits. However, in this section, we will broaden our definition. For any value of x that the limit exists at that we can determine the value of f prime of x, or the derivative of the function, we can use different notation to indicate the derivative of the function. So let's say we had y of x. We can write this derivative as dy dx, which would mean the derivative of y with respect to x. Now, with regards to the exponent rule, we know that this x value has an exponent of 1. So when we take the derivative of this x, we will put the 1 in front, multiply by x, and the exponent will be subtracted by 1. This means that we will be saying that 1 times x to the 0, which is actually equal to 1. Similarly, we can have something like x squared, and we will bring down the 2 in front when we take the derivative. We will put the same variable, and we will subtract the constant by 1. So the derivative of x squared is actually equal to 2x. Now we can try a more complicated problem like x cubed minus x squared plus 4x, and that is going to be equal to 3 times x, 3 minus 1, which is giving us 3x squared. We already know what x squared is from the previous example, so minus 2x, and we can use similar properties that from 4x we can say this is going to be left with 4, because 4 times 1 multiplied by x, 1 minus 1, which is going to equal 4. Now we have the constant derivative rule, which states that when we derive a constant value, for example y equals 4, the derivative of this will always equal 0. So the f prime of x, or y prime, would equal 0. And why is this? Well, if we draw this out, this graph, this is a very rough sketch. At y equals 4, the derivative, we know, is the rate of change. When we look at the graph y equals 4, there is a rate of change of 0 because the function is not changing. When we have the derivative of, say, y equals x, we know that the function is changing 1 unit in the x direction and 1 unit in the y direction. Therefore, our derivative is equal to 1. So this kind of makes sense. There's a lot of continuity in concept. But now we have a couple of rules when we are taking the derivative. So let's say we had something like y equals x squared over 4x. Now, we can also say this is equal to x over 4, okay. But when we take the derivative, we still have a denominator and a numerator, and this gets a little bit complicated. So we can say y prime is equal to low d high minus high d low over low squared. Now what this means is the low, or the denominator, times the derivative of the numerator subtracted from the derivative of the denominator times the numerator, all over the denominator squared. So we can write this out, and we're going to use the simplified form. We can say low, which is 4, times the derivative of our numerator, high, minus our numerator, high, times the derivative of our denominator, low, over low squared, 4 squared. And now we can say we know the derivative of x is equal to 1, so we have 4. We know the derivative of any constant is equal to 0, so any number times 0 is going to be 0. And we know that 4 squared is equal to 16, so this is actually going to be 1/4 is the derivative of x to the 4th. Now this is a little bit misleading because you can say, oh, why don't we just take the derivative of the numerator? But when we get to more complicated functions, that's still not going to be the case. Now we have the multiplication rule. Let's say we had a value multiplied by x squared, so we'll deem this k. We know that this value is being multiplied by x squared. It's not a constant, so don't be fooled. But when we want to derive this function, we can't just simply state that it's going to be 2kx, because that's not always going to be the case. So we can say that y prime is actually going to be equal to the derivative of our first function, our first value, multiplied by the second value, plus the derivative of our second value multiplied by our first value. And that'll give us the derivative of this entire function. Now, what's important to note is that the order of this does not matter. However, the order of the division method does matter. So it's important to notate and understand what you're doing when you're doing both the product and the division rule. If you have any more questions or need more help, there is a bunch of resources on the website. Thank you so much, and I hope that helped.